Problem 21 is one that some people just race right through and get the answer lickety-split, and some people really struggle on that one. To be honest with you, I'd prefer if you were one of the people who was struggling on this a little bit, because I think if you race through and just take a shot in the dark and then check your answer and find out you were right, you were really just guessing at this problem. This involves a concept that we are going to learn formally in section 3.9, so we'll get there. But for now, we're going to try to treat this like a normal problem from section 3.7, which is a chain rule problem. And in a chain rule problem, we usually like to take the original function and break it down into an f of x and a g of x. And if you remember, that f of x is usually the outer part of the function, and that g of x is generally going to be the inner part. So as I look at my variable here, which is x, obviously I see it there in my exponent, the first and most immediate thing happening to it is that they're subtracting 12 from it. So that x minus 12 is the inner part of this function right here. That's what I would call my g of x. Then, what is happening to the quantity x minus 12? They're exponentiating it. So our outer function, f of x, is e to the x. So really what's happening here, guys, this is a step that isn't necessarily a bad one to write, that y could just be written right there as that composition right here of f of g of x with these two definitions that we wrote over here. Well, if you recall now, the derivative of y taken with respect to x, using the chain rule right now, is to take the derivative of the outer part while leaving the inner part alone. So you didn't really need to write this, but it's f prime, and then we leave the inside just the way it was, and then multiply at the end now by the derivative of the inner function. That would be g prime of x. So does that help us here? Well, it does, although a lot of you might not quite see it. What do we begin with? F prime. We take the derivative of the outer part, which is e to the x. Now again, let me get the word x out of my language right there. We're tempted to say, because we learned early on in this chapter, that the derivative of e to the x is e to the x. True. But what we really want to be thinking now is the derivative of e to a power is the same base, e, raised to the same power. So that's us now leaving the g of x alone, and we're still going to start off with an e to the x minus 12. And all we're going to do now is multiply that by the derivative of what's inside, the derivative of the x minus 12. But in this case, that derivative of x minus 12 is just 1. So our answer here, guys, dy dx, is simply equal to the exact same function that we started with, e to the x minus 12. Now, I feel like they missed an opportunity here to have you guys do something more interesting. So just for the sake of argument, what if I had said now that instead of an x minus 12, this was a 3x minus 12. How would that have changed things? Well, on this step right over here, we would begin by taking the derivative of e to any power is still e to the same power, which is 3x minus 12, but then times the derivative within. Now we would have been multiplying by a 3. So our answer then would have been a 3 times e to the 3x minus 12. And I think that would have been a little bit more interesting here than what we have. I don't want you guys walking through a problem like this and saying, okay, anytime I take the derivative of e to any power, it's always the exact same thing that I started with. I can see why you would say that if you said, oh, the derivative of e to the x is e to the x. It's exactly the same. Or with this example, the derivative of e to the x minus 12 is e to the x minus 12, the same thing again. So you might look at this then and say, okay, well, if that derivative is equal to that again, then I can conclude that the derivative of e to any power is always the exact same thing. Well, the example I had just a second ago is a counterexample to that. The derivative of e to the 3x minus 12 would have been 3e to the 3x minus 12. And that tells you it is not true that the derivative of e to any power is just equal to the original function. It is true in certain cases, but it's not true in every case. The key here is, guys, if the derivative of your exponent is 1, then yes, the derivative of that function is the same as the function itself. That happened here as well. The derivative of the exponent is 1. So therefore, our overall derivative is the same as the function we started with. But when that derivative of your exponent is something other than 1, then you don't end up with the exact same function again. So be careful about looking at one or two examples and trying to draw a universal conclusion from that. You can get yourself in trouble that way sometimes.